All right.
So that's the final product, but how it works is more interesting than you think. We had to dive deep into machine learning, tear apart a Spikeball net to replace the insides, and just have a ton of fun playing Spikeball. To understand this project, I'm gonna have to take you back to the beginning of the 2020 school year. Our high school is all online this year, and we have a massive lunch break that the administration gave us so that we can do more work. So we've gotten into Spikeball. Spikeball is kind of a mix between volleyball and foursquare, except with the little yellow ball. The rules are pretty simple. It's 2-on-2, and after the serve, each team gets 3 hits to get the ball back to the net. The point ends when a team can't get the ball back to the net, when the ball hits twice, or when the ball hits the rim. But there's kind of a gray area there, with what's rim and what's net. Everybody who's ever played Spikeball knows what I'm talking about. There's really no easy way to tell the difference.
That was pocket. That was pocket. That's our point.
No, that's
the rim. You can't just catch it.
Hit the rim.
So this is how we build a net that can tell the difference for you.
We had a few possible designs in mind, the simplest of which would just be putting some touch sensor around the rim to register when the ball touches the rim versus the net. Another pretty simple design would be some sort of net stretching sensor that could tell the difference between the pocket where it would stretch the net a little bit and the rim where it wouldn't stretch the net at all. You're supposed to be able to hear the difference, so we thought about putting a microphone down by the rim, but with people running around and talking to each other, that really wasn't going to work. But what we eventually decided to go with is a vibration sensor. It's called an IMU. It's the same thing that measures the orientation of your phone. And this is what it looks like. Well, actually, this is the IMU. And it's not really a vibration sensor, it's more of a motion sensor. But if you take the change in that motion, professionally known as jerk, then it turns into a pretty good measure of vibration. So we slapped it on one of the Spikeball legs, and it detects everything. It can detect normal hit, light hit, barely touching the rim, even if the ball completely misses the rim. So how do you tell the difference between this and this, when all you have is this?
Here's the problem. Even though a rim shot tends to cause more vibration than a pocket, you can't just look for high vibration, because a hard net hit still shakes the rim more than a soft rim shot. The computer needs to be able to tell the difference between these and these. So the first thing we gotta do is isolate the graph of any kind of hit. It needs to take something like this and turn it into something like this. And this wasn't too bad. If the horizontal jerk reached a certain threshold, the computer would log those numbers and export them as some kind of hit. That way it filters out noise and stomping near the net and anything else you wouldn't want to see.
So then we take that data, and here's where the machine learning comes in. Machine learning.
Peter, no one wants that.
There's a lot of good videos out there about machine learning. We put some of them in the description. But basically what it does is you give it a bunch of data, and it finds the patterns in that data and uses those patterns to make predictions about future data without us having to do anything more than just give it a bunch of examples of what's a net and what's a rim. It's the same way that self-driving cars work. You give it a bunch of training data, and eventually it'll be able to recognize stuff by itself. Now there could be other ways to do this. Maybe rim hits have a faster spike at the very beginning and level off sooner, and net shots take longer to smooth out. But what we wanted to do is let the computer figure out those patterns. After some basic training with encouraging results, and after working on a few kinks, it worked.
So we put it all together in this 10-second montage.
We ended up needing the space inside all 5 of the Spikeball legs to fit the electronics. The machine learning algorithm is running on an Arduino inside one of the legs. It receives power from batteries stored in a separate leg. There's LED lights stuck around the inside of the rim the whole way around, and they double as a way to transfer power to all the different electronics. There's speakers stored into the legs so that we can play sound effects, and a Bluetooth receiver in the final leg so that those speakers can also play music from your phone.
After all that, the net was finally ready for some real play. We invited some friends and took it up to the field for some testing.
All right.
And we also added this. The net's got 3 settings. Least annoying, where it's just white and flashes red if you hit the rim. Kind of annoying, cool colors going around, brighten up when you hit the net if you hit the rim. Then stupid obnoxious, where it insults you if you hit the rim.
You suck!
Oh!
You suck!
And if you're playing sound effects, might as well add some music. What do you think of this net?
I love it. It's really easy to tell when there's a pocket or it's a rim.
I love it. You know, I've tried them all. Slammo, Spikeball. It's wonderful. You can tell when it's a rim or not. I don't have to fight with my brothers anymore. Let me tell you. 9.5 out of 10.
What's the 5?
I wish there was more you suckage, because that's the best part.
We got it up to somewhere between 95-99% accuracy. Some of the issue might have been where we trained it. We trained it out back on our grass, and when we took it up to the turf, it probably changes something.
Big thank you to Spikeball for supporting this video.